This question asks us to assign the hybridization for the indicated oxygen atoms and to predict which one is most stable. Both of these oxygen atoms have one bond and 3 lone pairs. That makes it seem like both of them should be sp3 hybridized. But look at the oxygen in the carboxylate. The oxygen in the carboxylate can engage in resonance. We can use one of the lone pairs on this oxygen to form a pi bond between carbon and oxygen, breaking the other CO pi bond, involving a new resonance contributor. In order to be involved in resonance, that lone pair has to be in a p orbital. And if it has to be in a p orbital, it can't be sp3 hybridized. Therefore, the oxygen in the carboxylate is sp2 hybridized, whereas the oxygen in the alkoxide is really sp3 hybridized. There's no possibility for resonance in the alkoxide, and so it really is sp3 hybridized. Which one is more stable? The lone pair of electrons on the sp2 hybridized oxygen can engage in resonance that spreads electron density out over a larger volume. Whenever we can spread electron density out over a larger volume, that makes the electrons more stable, and anytime we stabilize one part of a system, we stabilize the whole system. Therefore, the sp2 hybridized oxygen on the carboxylate, because it can engage in resonance, the carboxylate is the more stable structure of this series.